Hey everybody, this lesson today is going to be for Thursday the 19th. Okay, I'm going to put it up a little bit early, but if you want to get a head start on it, it's going to be over 4x1 multiplication. So really it's just building off what we did in our last lesson with 2 and 3x1 multiplication, just getting a little bit more complicated, kind of expanding on what we already know. So just a few reminders before we start. Make sure you're practicing your single digit multiplication facts. You may want to brush up because I'm not going to spend a ton of time going over again the actual algorithms, both the standard one and the area model. So if you want to make sure on that, check our last video. But we're just going to dive right in and start talking about 4x1. So again, if there's any questions, ask me in the class, shoot me an email, and we will figure it out. Okay, so flipping it over to this way, let's take a look. Okay, so if we were going to look at multiplication 4x1, that might look like 1,325 times 5. We'll start out with that, okay? Now, this may look a little bit daunting, but in reality, it's the same way that we would do any problem like this, whether it had 2 digits on the top, 4, 5, 6, 7, 8, whatever, okay? So we just follow our steps, take our time, okay? First thing, let's line it up correctly. And first, we're going to start with the standard algorithm, okay? 1,325 times 5, making sure we line up our ones place. 5 times 5, 25. 5 in the ones place. 2 over that 2 in the tens place. 5 times 2 is 10, plus 2 is 12. So 2 in the tens place, 1 over the 3 in the hundreds place. 5 times the 3 in the hundreds place is 15, plus 1 is 16, and 5 times 1 is 5, plus 1 is 6. 6,625. So what we'll do now is we'll do that same problem looking at it with an area model. So as we remember from the area model, first we draw a box. And this time, because there is more place values, there's going to be more divisions of this. So when we think about this, remember, we do this in order to differentiate the size of each of them, okay? And we think about it as its expanded form. So we have 1,320 and 5, because that would be the expanded form of 1,325. And on the left over here, we put our single digit, and we're multiplying by that 5. And now we go through it. So 5 times 1,000, well, 5 thousands is 5,000. 5 times 300, well, 5 times 3 is 15. 5 times 3 hundreds is 15 hundreds, or 1,500. 5 times 2 is 10. 5 times 2 tens is 100. 5 times 20, right? 5 times 5 is 25. And now we add these up. So we should get 6,625 if we did this correctly. 5,000, 1,500, 125. And as we look, making sure that we can see, and I'll even, I guess I got to move the camera. You can see 6,625. Okay? Just remembering to make sure that we take our time with the expanded form, set it up correctly. But the nice thing about the area model is you can pretty much do a lot of the math in it if you are good with your single digit multiplication, almost in your head, right? 5 times 300, well, that's 15 hundreds, right? So let's do another one. If we were going to look at, we'll say 3,361 times 6, okay? And just to relate this, let's remember if we added 3,361 6 times, we would get the correct answer. However, that would take a lot of time and just be a pain. So let's solve this with multiplication. This time we're going to start with the area model, okay? So when we draw our area model, we know we're going to have this many divisions in it because of the place values, and we break it into its expanded form. So 3,360 and 1, and we multiply by 6, okay? So that's how we set that up. 6 times 3,000 is 6 times 3 is 18 thousands, okay? 18,000. 6 times 3 again is 18, but this time it's hundreds, or 1,800. 6 times 6 is 36. 36 tens, right? Because that's 6 tens, looks like 360. And 6 times 1, any number times 1 is itself, so it is 6. Now we add these up. We have 18,000, 1,800, 360, and 6. So we have 6, 6, 8 and 3 is 11, 9, 10, giving us 20, make sure we can see that, 20,166. So let's put our answer up here and check it using the standard algorithm, okay? Let's take a look at this. So if we did 3, 3, 6, 1 times 6, making sure we line it up correctly, because again, when we get that number on the bottom of the tens place, it's really important that you get everything lined up correctly, okay? 6 times 1 is 6. 6 times 6, 36. Put my 6 in the tens place, my 3 over that 3 in the hundreds place. 6 times 3 is 18, plus 3, 21, And there's my 2 and my 1. 6 times 3 is 18, plus 2, 20. Verifying our answer. Again, just because we're doing it a different way, it does not change our answer whatsoever. The thing about these strategies is you're always going to get the same answer if you're doing them correct. It's just a different way to do multiplication. Same result, different way to get there. Okay? Let's do one practice one in case you missed the lesson and you would like a little bit of practice yourself. Okay, let's do 2,743 times, we'll say 3. Okay, 2,743 times 3. So I'm going to pause for about 5 seconds and then we will go over it. Okay, hopefully you paused that there. You worked it out yourself and you're going to be able to compare your answer. We're just going to do this one way now. Let's do this with the area model and then you can check your answer. Okay, so let's take a look. If we did this with the area model, okay, boom, 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 okay. And remember, if we're doing this perfectly, you want to have the amounts be represented in the rectangles. However, it's not going to change your answer, so we're going to ignore the fact that Mr. G just made them all the same size, okay. So 2,743 being the expanded form there, and we're going to multiply this by 3. 3 times 2,000 is 3 times 2, which is 6,000, because it's 2,000. 3 times 700s, 3 times 7 is 21 hundreds, or 2,100. 3 times 4 tens, 3 times 4 is 12 tens, or 120. And 3 times 3 is 9. Now we add these up, 6,000, 2,100, 120, and 9. And we add them up, 9, 2, 2, 8, giving us our answer of 8,000. Oh, can't see that on there. 8,229. Okay? So, like we had said, the thing with 4x1 multiplication is it's the exact same as 2x1, 3x1, just with more steps. So, again, make sure you're doing best practices, line it up, take your time, try both strategies, but it is okay to have one you're slightly more comfortable with. But keep in mind, it's important that we understand all of them because there are certain kinds of problems that we're going to get into that favor one or the other. And it's just great to know multiple ways of doing multiplication, especially because when you have a variety of strategies you can do, you're really deepening your knowledge of math itself and really starting to understand the process behind it all. Okay? So, like always, stay safe, ask questions if you got them, and I will see you guys in class.